You have learned about probability for a few years now. Let's apply this to geometry and look at geometric probability. Remember that in probability, the set of all possible outcomes of an experiment is called the sample space. Any set of outcomes is called an event. So if every outcome in the sample space is equally likely, the theoretical probability of an event would be the probability of the number of outcomes in an event over the number of outcomes in the sample space. So essentially, it's what happens in your event, and this is the total amount. So geometric probability is used when an experiment has an infinite number of outcomes. The probability of an event is based on the ratio of geometric measures such as length or area. The outcome of an experiment may be points on a segment or in a plane figure. Let's look at this chart for a minute. This is in your book, so you do not need to copy it down. But this is what it would look like if you're talking about length or points on a segment. This could be about angle measures, remembering there's 360 degrees in a circle. Or maybe you want to find what's the probability of getting a point in the triangle. So you have the triangle out of the whole rectangle. So let's look at some examples. A point is chosen randomly on segment PS. We want to find the probability of the event happening where the point is on RS. So if we look here, the total sample space using your segment addition is 25. So the point to be on RS, the event is 5, and the sample space is 25. So the probability of getting a point randomly on RS would be 1 out of 5. But let's look at the probability of the event happening where the point is not on QR. So if they want that not, let's see what it would be to be on QR. So to be on QR, it would be 13 out of 25. So now, the probability of it not being on QR, if we have a probability of 1, that means it's going to happen no matter what. So if we want the not, we want to take the 1 minus what could happen, and when we subtract, the probability of a point not being on QR is 12 out of 25. So that's just applying basic probability to our segment. Let's look at some more. What if a pedestrian signals at a crosswalk has the following cycle? It blinks walk for 45 seconds and don't walk for 70 seconds. So what is the probability the signal will show walk when you arrive? Well, the probability for walk is 45 out of the whole 115 seconds, which reduces down to 9 out of 23. So the probability of it showing walk is 9 out of 23. Use this information below to answer this to be ready for class. What is the probability that the light will not be on red when you arrive? Do this and be ready to show your answer in class on Friday. Let's look at a circle with angle measures. Spinners are very common with circles, so let's use the spinner to find the probability of the pointer landing on yellow. So here's the yellow, and the probability would be 140 degrees out of the total 360. And when we simplify this, the probability is 7 out of 18. It could be as simple as that. Now I want you to try one to be ready for class next time, and use this spinner to find the probability of the pointer landing on red or yellow, remembering that that word or means you need to add. So have this ready in class for Friday. Now let's start looking into the area and perimeter, what we're talking about with this unit. What would be the probability that a point is chosen randomly inside the rectangle could be in any of those shapes? They want us to round to the nearest hundredth. Well, first let's look at the different shapes. We have a circle right here. We have a trapezoid, which is here. And then we have two squares. And we just want the probability of it being in any one of those shapes. Notice the circle and the trapezoid overlap. So if it's in the circle, wouldn't it also be in the trapezoid? So what we need to do is find the area of the rectangle. Which is going to be area is base times height, which gives us 50 times 28, which is a total of 1,400 square feet. So now let's look at our circle. Our circle, we have an area pi r squared where our radius was 9 feet. So we have pi times 9 squared, which is 81 pi, which is approximately, since it said round to the nearest hundredth, is approximately 254.5 square feet. So now the probability for the circle would be the 254.5 out of the whole 1,400. The probability of being in the circle is approximately 0.18. So you notice we just found the area of the circle, the area of the rectangle. Circle was our event, rectangle is our sample space. So we write that ratio and we get our probability. Let's look at the trapezoid. And notice how I've been labeling everything. If colors help you, then do it in colors on your paper. But you definitely need to label what you're doing. So remember, the trapezoid is 1/2 base 1 plus base 2 times the height. So we have 1/2, base 1 is 34, base 2 is 16, and our height is 18. When we simplify that, we get that the trapezoid has an area of 450 square feet. So the probability for the trapezoid would be 450 out of the 1,400, which is approximately 0.32. And then last but not least, let's look at the square. The area is side squared. The length of the side is 10. So the area is 100 square feet. Now we have two squares. So we're actually looking for a total of 200 square feet. So the probability for being in a square would be 200 out of the whole 1,400, which is approximately 0.14. So these are your three possibilities for landing in a circle, landing in a trapezoid, or landing in a square. Now that you have all the information, you could answer questions such as, what would be the probability of it landing in the circle or a square? And remember, with or, you have to add. So we would just add those two probabilities and find our new probability. This last slide on here is what you're going to do to have ready for class. So find the probability that a point chosen randomly inside the rectangle is not inside the triangle, is not inside the circle, or is not inside the trapezoid. Remembering that word not means you need to find what's the probability of it being in the circle, or being in the triangle, or being in the trapezoid, and subtracting each one from 1. It says round to the nearest hundredth. So like I said, have these questions from this video ready to discuss in class on Friday. Again, if you need me, I am here for tutorials and I will help you through it.